basically looking at a reactor, as you can see on the right, with two different thermal systems. There is a cooling water system for cooling and a steam system for actually heating. And as the reactions go on, every time they have to go to a heating phase to bring the reactants to temperature, make the catalyst active, and then at the end, when the polymer was formed, they would have to go through a cooling phase, cool down to about 10 degrees before they could actually start post-processing and discharging the product. And it is known that, well, the cooling part is, there's no new product formed, so the reactants have already gone to full conversion, or at least the maximum attainable conversion. And this cooling phase is therefore very time-consuming, and no new product is formed. And this problem is compounded as the heat exchangers are starting to foul. This phase becomes longer and longer, and well, this is time that is not used for production. So therefore, we want to actually monitor this fouling on the cooling water, especially on the cooling water heat exchanger, to make sure that this does not go too far. There's also a safety aspect, because of course, if you have an undesired situation, there is a steep rise in temperature. You need to make sure that there is enough cooling capacity available. So in these emergency cases, the full cooling capacity can be used to actually halt the reaction, bring it to a stop, and safely bring back the reactor to a normal temperature. Now, of course, the problem is here that this reactor is not exclusively used for a certain product, and it's very difficult to for a process engineer to monitor each of his reactors. There's maybe 20 or more, and each have different cooling times. So it's very difficult for a process engineer to follow this up. And it's next to impossible to actually see evolution over time and say, okay, now is the time to actually schedule maintenance, let alone schedule maintenance in time before it's actually too late. So that is something that you want to avoid. When we look at this problem in TrendMiner, and let me start a new session, very easy. I actually want to look at this problem, second example, where again, this is a very typical batch profile, as I explained. If I zoom into one of them, you notice that indeed in red, you see my temperature. So there's an initial rise during the heating phase, and then during the cooling phase, I'm actually just cooling down towards a certain threshold so I can discharge the reactor. What I want to do, and this is very easy in TrendMiner, is I want to get an idea of how long do these cooling phases take, and what is the difference that I can expect between a very good cooling phase and one where the heat exchanger is severely fouled. So what I'll do in TrendMiner is actually do a value-based search. I'm going to look for this particular phase in my reactor, so I know the cooling phase is actually phase number 3, and I want to find those periods where my temperature is actually still higher than 10 degrees, because that's, for me, that is the time-consuming part. That is the phase that is of interest for me. And let's say I'm looking for at least, let me say, 15 minutes, because of course a normal cooling phase takes at least 15 minutes or longer. And when I search for this, you notice right away I get those results. For the last about 5 months, I have in my my active time list here in the bottom. So I go from November more or less to start of April. It's about 5 months. I get about 300 results. So I get 300 batches. And of those batches, I want to sort them, or on those time frames, I want to sort them on duration. And as you can see, my shortest ones, I get a bucket between 30 minutes and 40 minutes. About 50 of those batches are between 30 and 40 minutes. So those are my shortest cooling phases, and I can select one of those if I wanted to. Let me select the shortest one, for example. And let me zoom out a little bit to see more of this reactor phase. This is a very short batch for me. Let me look at one of the longer ones. So let me just go back. And I see that, well, actually, I have 3 batches that take between 80 and 90 minutes to get to that same stage. So very slow compared to the one I was looking at before. And let me add one of those. And you see it indeed very clearly. And let me zoom out a little bit more just to get a whole batch view in there. You notice indeed that I start from a similar temperature level. And when my probably when my heat exchanger was just cleaned, it goes very fast. While to get to that same threshold of 10 degrees, it takes a lot longer for that final batch. And the difference is about 1 hour, so it's quite significant. It takes 1 hour longer before I can actually start post-processing that batch and actually start discharging. So just an hour of lost time on that batch. Now, what I want to do now that I have let's say analyzed that there's almost 1 hour of difference, I know that my shortest batches take about 30 minutes. What I want to do is actually set up a monitor in the background that's now going to warn me whenever this batch takes, let's say, for example, it takes more than 45 minutes to get to 10 degrees, because I know when it starts taking longer than 45 minutes, that's when I need to start scheduling maintenance, because, well, it might take another week or maybe even 2 weeks before that maintenance can happen. And of course, over those 2 weeks, the problem is even going to compound even more. So let's say when I know it takes about 45 minutes, that's really when I need to start scheduling that maintenance. I can search again. I know indeed that I found about 180, so about 2/3 of the batches would fall into that category. So a good slice of the batches are actually taking too long already. But I want to actually set up this search, and I can save it now, and I will call this webinar cooling batch example. I can save the search because the mantra in TrendMiner is everything I search for, I want to be able to monitor for. So when I save the search, it will now automatically appear in my monitor and alert menu, where I can say whenever this situation occurs, whenever TrendMiner finds a matching pattern in the background, I want to be warned. So I want to maybe send a message to my in-application inbox, so every user has an inbox inside of TrendMiner, but I also want to be warned by myself. So let me send an email message to myself with headline reactor XYZ heat exchanger fouling, with maybe a message for myself saying cooling phase longer than 45 minutes. And if I wanted to, I could also automatically annotate my data so that every batch that takes longer than 45 minutes to reach that threshold would get a little annotation. So I can also, when I'm browsing through my data, I can immediately see which batches are good, which batches are bad, and do something, use that for a search, for example, later on. But in this case, that's not so interesting to me, so I'm just going to save this. And when I turn it on, TrendMiner is now going to look for this pattern in the background and start warning me whenever this happens. So I don't have to manually every morning go through my reactors, or every morning try to wade through all the data to find this problem. No, I'm just going to be warned whenever this is occurring, and I can take the appropriate steps if I need to engage that. Okay, so in the case of our customer, this kind of monitor that I set up in about 5 minutes now, it was set up for the most frequent products that they are running inside of their organization for their key reactors. And as soon as the cooling phase starts to increase, that warning is issued to the engineer, and he can take appropriate action. He can start that procedure to get the maintenance. Clear benefits, of course, is that first of all, there's less downtime. You lose less time actually cooling your product, which is time-consuming, but not, let's say, a yield-improving phase. And overall, this insight, this warning system, it's resulted in an overall revenue increase of that production line of over 1%. So quite significant for such an easy task to set up for the engineer. Once again, scheduling that maintenance will also avoid additional stress on your equipment. The safety risk that I explained earlier, where you always have sufficient cooling capacity, is now also taken care of. So quite a lot of benefits for this easy workflow, basically.